everyone. Sounds good. Good afternoon, everyone. My name is Nima Polladi. I'm from Europe, and I studied my second PhD at the University of Miami with Professor Anthony Tony. And based on my previous PhD, most of my work were related to the artificial intelligence. And in civil engineering, we try to combine both the computer science and the civil engineering together. And today we have one presentation about the FRP-RC slab base. And our group is Professor Antonini, me, and Francisco Picasso, and we have another person that I forgot to mention his name. Maybe later I will find it. Okay, the overview is that why we want to work on this study. First of all, we have a lot of interest for using the FRP in the concrete slabs. And the other thing is that FRP always offers a transformative approach to construction materials. And it has a lot of advantages like a lightweight, high strength, corrosion resistance, insulation, and fatigue resistance. And we have a lot of application when we need to have a structure in marine area because we always face corrosion here. FRP-RC slabs, it's really complex, and we have a lot of formula, and we have some codes like the Japan codes, like the kernel, like ACI. But because we have a multiple interaction parameters, and there are a lot of parameters, sometimes it is more related, and sometimes it is not the accurate number you cannot get it. And this is one of our motivation. And the second one is that we have a limitation of the current models, less mathematical formula that we have, and we need to have a more strength, applicable model for the real engineering usage. Maybe some of you are not familiar with the machine learning. Because of this, I always try to talk just a few minutes about the machine learning, and then we can go to our application. I myself believe that artificial intelligence is not artificial, because all of us know that we create that artificial intelligence, and we are a part of the nature. And during my PhD, during my first and second PhD, I developed more than 10 algorithms related to the machine learning, and I got all those inspiration from the nature. And I believe that this is the nature intelligence, not artificial intelligence. Just to see my opinion, maybe somebody they didn't accept it, but it's just my opinion. The machine learning is an application of the artificial intelligence that involves the algorithm and the data, that automatically analyze and make a decision without any human. And it describes how computer performs tasks on their own by previous experience. And we can say that in the machine learning language, artificial intelligence is generated on the basis of the experience. And experience here is our data. There is a huge difference between the traditional programming and machine learning. In the machine learning, we always have our data, and we have our output, and then by programming, we can get our results. But in a normal computer, we don't use our data. We create our program, we create our formula, then we feed our data to get the output. This is the main reason between the machine learning and the traditional computer model. And there is a difference between the machine learning and AI. Sometimes, even if in some conferences, some people believe, I don't know, they believe, or sometimes they say that we did AI, and maybe they say that machine learning is equal to the AI. It's not equal to the AI. It is a subsection of the AI, and it is just like tools in the AI that we can use. Here in this study, we are going to use the XGBoost. The first question maybe sometimes we had in our mind that why XGBoost, why this algorithm? As you know, we don't have any free lunch in ACR, okay? And there is no free lunch theorem. It says that you cannot find a specific algorithm that works for all data. And because of this, then we want to create a model. We should, develop different models, and after that, we compare different models to get the best algorithm. XGBoost is an extreme gradient boost algorithm that's powerful, and iterative learning algorithms. We always say that for the decision tree is just one tree, okay? But for the XGBoost, it is a part of the iterative different decision tree model. And because of this, the XGBoost is so powerful algorithm. It has another algorithm. Yeah, I forgot to mention my team member. This guy is Mr. Grey Goose. Mr. Grey Goose is our latest Inspire algorithm that we developed and we published in an expert system with application, one of the computer science journals. And yeah, he's right. He said that I didn't do anything. We did the optimization for our problem. In most of the machine learning algorithm, we have different parameters. Because most of the time we just use the algorithm, we didn't have any background about this hyperparameter. And the most important thing is here that if you can tune the hyperparameter, you can increase the accuracy of your model. But here we have some algorithm in the Python, in some libraries like grid search, that are really good. But the problem here is that sometimes they got stuck in a local optimum. And for this reason, they couldn't get the global optimization, global optimum. Then we develop algorithm like a meteoristic algorithm. They are not exact, they will not get the exact solution, but we will get the approximate solution, but we will never get trapped in a local optimization. And because of this here, we combine the XGBoost with our GGO with optimization to tune our 4 essential parameters like learning rate, the max steps and minimum requirement and regularity. We did this for our method. Why we use the XGBoost? It is really good algorithm for us because it has some advantages like we can do parallel tree building. There is no need to hire high computing, low runtime, and the high model of the performance. Besides all the advantages that the gradient boosting algorithm has. Okay. In this study, I gathered more than 189 experiment data set from the 32nd distinct research. And these are our distribution of all parameters. We have the loading area, shape A and B, loading area dimension, B and C, effective depth, concrete strength, FRP young modulus, and FRP ratio, and the punching shear strength statistic will be our output. But the problem here is that the data is not too much. This is until the 2024 from 1964, I see. And for the AI, you need more data. If you have more data, you will get good results. the data is the essential part. If you feed your models with the garbage, you will get the garbage. And because of this data is essential. Then I come up with this idea how we can use a generative AI to create some data. Because if you can create more data, you can improve the model robustness, you can balance the data, you can expose the noise, and expand the sparse data set, and you can explore future spaces. For this reason, I use the kernel density estimation, KD. The KD is a non-parametric probability density estimation method that you can get the data distribution and without making any distribution assumption before. We don't know any assumption. We cannot put any assumption on our data. And for this reason, we use the KDA. And then we gather data. As you see here, the red one is our synthesized data. Sometimes we call it a fake data, okay? And the blue one is our original data. And then if you see the distribution is the same, and it shows that our fake data, our generative data is really good. And we created 500 generative data, and now we have a 689 data. Then I come up with this another idea. Okay, I want to use this data. How can I use it? I created two models, N1. In the N1, I used 80% for the training and 20% for the testing. And in N2, I didn't use the I keep all the tests, all this experimental as a test, and I use the training, the generative data as a training. Because with the training data, they are from the fake data, and we have the experimental that we know that this is the result. I can compare it really good. And then I found out that the N2 model is worked very well, as you see in the diagram. And here's the result that we got it from the N2 for the training. It's 90% accuracy, and for the test is 95. But if I want to use just 189 data, I can get just 87% for the test. And then I compare with some of the well-known machine learning algorithms like LR, SVM, backpropagation, decision tree, and RF to compare that our algorithm is better than the others. And here, I gathered the literature review, and I found out that Japan has a formula, then Canada standard has another formula, ASC has another formula, and there is another literature review. They gave a formula based on the critical shear crack theory. And then I used our own data, 189, and I feed it to all these algorithms. And these are the results that we got. And as you can see that, for example, for the CSA, JCA, and ACI, the R score is not very well, okay? And these are the same data that we have, but if we feed it into our machine learning algorithm, we will get 96% accuracy. And it shows that the model is really good. And then I want to show that which of the parameter is really important in our data set. I found out that the depths of the our model, yes, and the B and A and B are the most important parameter. Then I did some sensitive study of our parameters, and I saw that if we increase these parameters, we can gain more state shear. But maybe you ask me a question, okay, if you use one specific experiment, for example, for Mr. X, okay, they did some experiment, and they didn't change the D. They changed the A, they changed the B, they changed the row, okay? If you create a model based on that, in that model, the D is not an important one because you never change the D, okay? SHAP model always look at the old data set, okay? But if you want to create a model based on that, you cannot say that my model is really great. No, you cannot say that. For this reason, I use the shallow water fault plot, okay? In shallow water fault plot, I took two experimental from Dr. Hassan and Dr. Fred, and I noticed that from those, if you see that the D for his study is a negative, and Mr. Fred, the D again is a negative, okay? And it seems that if we use our model and it doesn't work very well for this kind of example, we will get the worst result. But as you see, for example, he got 329 kilonewton and we got 338 kilonewton. And the error is just 2.7%. And for other experiment, it shows that the guy got the 548 kilonewton shear and our model got 555 with the error of 1.3. It shows that even if some of the experimental, they didn't change the D, they didn't change the rho, okay, our model is not a bias. When we said that it's 90%, it works very well, it works. If you have a new data in experimental and you did it, we can use this software to obtain the results. The conclusion here is so obvious. The first one is that we can use the KDE to boost our model. The second one is that because we had a limitation for the models, we create the software, we create the model to use it. And for all our other design code, most of them were less than 80% accuracy. And the superior of the performance on our XGBoost, we got it. And we found out that the effect of the depth is the most impactful factor in our study. And this is our software, we call it GUI, Graphical User Interface. We developed this software, and for some people that they don't like to use, coding, okay, and they don't know, and they are not expert in the coding languages. It's like a calculator you can put, and as an input you can use the numbers, and just with one click you can get the results. And this software is free, and you can find it in my website. If you go to our website, you can see that we have a different algorithm that we publish it as a free, that most the scientists can use that one. And in the software section, you can go and get most of the application that we develop, and it's free, and there is no need to have any other application. You can just install it on your computer. And thank you very much for your attention. We had some other participants here, like NSF, CICI, FISM, and I would really appreciate it for all of you to come, and I hope I can do something. Thank you very much.
Thank you. Any questions from